Right, this question 16 from winter 2022 paper wants us to use bond enthalpies to find the enthalpy change of a reaction. I'm going to rearrange the setting of this question so that we have more space to do the working. Right, so we are given a reaction. So I'm going to number the as reaction 1. Okay, we are supposed to find the enthalpy change of reaction 1. And we are given more reactions. So I'm going to number them as 2, 3, 4, and 5 so that it is easier for us to talk about it. Okay, talk about them later. We are also given the bond enthalpies of different bonds here. So let's just look at reaction 1 because that is the reaction that we need to find the enthalpy change. So in this reaction 1, we have two reactants, gaseous carbon atoms, gaseous hydrogen atoms, and then an ethane molecule is formed. So this ethane molecule looks like this. This is the structure. It has a C-C bond, and then it has 6 CH bonds. Right? It looks like this. This is the molecule. In the reactants, they are already in gaseous atoms form. So okay, they are very far apart from each other. There's no bonding to be broken. Okay. Now to find the enthalpy change, for all reactions, what do we need to do is you will need to find the sum, okay, of all the energy of bonds broken, okay, minus bonds formed. Okay, why this formula? Because to break bonds, okay, uh, we need to supply energy. It is endothermic. Okay, to form a bond, okay, formation of a bond will actually release energy. So it became negative, okay, exothermic. That is why this formula. So you can see from here, to find enthalpy change of this reaction 1, okay, it's going to only involve the formation of bond because we do not need to break any bonds here in the reactants. So delta H for reaction 1 will be, okay, negative. Why? Because formation of all these bonds, okay, will release energy. So how much energy is released? We need to form one CC bond. There's only one CC bond. Okay, so I just put one. And also 6 CH bond. 1, 2, 3, 4, 5, 6. Okay, minus 6 CH bond. Because formation of bonds are always exothermic, so negative and negative. Right, we'll be able to find CC bond here in the list of bond enthalpies given. So I know this is 350. But okay, we are not provided with CH bond enthalpy. Okay, that means we have to find from reaction 2, 3, 4, or 5. So now let's look at reaction 2, 3, 4, and 5. Okay, which one do we use? It depends on the physical states of the reactants and products. Okay, which one is the closest and which one has the closest type of reactants and product, okay, compared to reaction 1. So reaction 1, we have gaseous carbon, gaseous hydrogen, then it forms an alkene molecule. So if I look at reaction 2, it looks quite similar. I have carbon, I have hydrogen, then I have an alkene, right? But the problem here is, in this case, okay, reaction 2, carbon is a solid. Hydrogen is still in a diatomic molecule form. Okay, so I try not to consider reaction 2 first because I need to actually vaporize the carbon. I need to actually break HH bond. Okay, let me check if I have a closer reaction from 3, 4, and 5. Number 3, okay, reaction 3, we have CH4. Now there's an oxygen that's involved in this reaction. Now reaction 1, right, there's no oxygen involved, and in the product, okay, there's no oxygen also. So I wouldn't consider reaction 3 at all. Let's look at reaction 4. Okay, a methane. Okay, we have alkane molecule in reaction 1 also. Gaseous carbon, gaseous hydrogen atoms. Very good because again, very same physical state, and also they are all atoms, right? So this uh, so far reaction 4 is the most suitable one. Let me just put a tick. Now let's look at number 5, carbon, hydrogen molecules, and then alkane, the hydrocarbon. Right, but still, okay, physical states are not very similar to reaction 1, just like reaction 2, right? So let me just cross 2 and 5 also and focus on number 4. Copy reaction 4 here. Now, reaction 4 delta H is given 1648. And to find this enthalpy change for reaction 4, okay, it would be the breaking of 4 CH bond, because CH4, the structure will look like this. Okay, and use this formula again. So delta H for reaction 4 will be ECH, 4 of them. Okay, products are gaseous atoms. Okay, so there's no bonds being formed in the product. So no energy is released from the formation of product. So delta H is only for 4 CH bond enthalpy. Okay, so 4 times equals to 1648. So what is the bond enthalpy for 1 CH bond? It will be 1648 divided by 4, 4, 1, 2. So you see that we have found bond enthalpy for 1 CH bond. So now we can use this value to find the enthalpy change of reaction 1. So we substitute this value into this equation that we haven't completed just now. So 6 times 4, 1, 2. Okay, so I have negative 350 minus 6 times 4, 1, 2. The answer is negative 2822, which is A.